Place a passenger jet from the 1960s next to one built today. The newer plane has better engines, smarter computers, lighter materials, quieter cabins, and far more advanced safety systems. But from a distance, they look almost identical. A long tube, two wings, engines under the wings, a tail at the back, cars changed shape, phones lost their buttons, computers shrank from entire rooms into our pockets. So why has the passenger plane barely changed? The simple answer: it has changed, just not in the places most people can see. And the reason begins with a design that solved several problems at once. Early aircraft came in dozens of shapes, but as passenger travel grew, one layout slowly won out: a narrow tube, two wings, engines, a tail. Not because it looked futuristic, because it worked. At cruising altitude, the air outside is too thin to breathe, so the cabin has to be pressurized, and that pressure pushes outward on the fuselage during every single flight. A round tube handles that push better than any other shape. A box-shaped cabin would need far heavier walls just to survive the same stress. The tube is also easy to divide: rows of seats, overhead bins, cargo below, doors along the sides. Put the wings near the middle and the aircraft balances itself. Hang the engines underneath them, and mechanics can reach every part without dismantling the plane. One shape, four problems solved at once. By the 1960s, manufacturers had converged on a layout that was safe, efficient, and endlessly repeatable. The same reason an Airbus A320 and a Boeing 737, built by rival companies on different continents, still look more alike than different. That still doesn't explain why it lasted 60 years, though. For that, we need to talk about speed. Most passenger jets today cruise around Mach 0.85, fast, but well below the speed of sound, not because engineers forgot how to go faster, because air becomes brutally hard to manage near Mach 1. Parts of the airflow around the plane turn supersonic before the aircraft itself does. Shock waves form, drag spikes, fuel burn climbs. Noise becomes a serious problem. Engineers pushed through that wall once. Concorde cruised at Mach 2.02, twice the speed of sound. But Concorde also showed the cost. It burned far more fuel per passenger than an ordinary airliner. Its sonic boom banned it from flying supersonic over land, and its narrow cabin came with a ticket price most travelers couldn't justify. It was retired in 2003 after less than 3 decades in service. Shaving a few hours off a flight wasn't worth that trade-off, so the industry settled into a narrow speed range, fast enough to cross oceans overnight, slow enough to stay profitable. Once speed stopped increasing, the shape stopped needing to change. The improvements just moved somewhere else. Compare an old jet engine with a modern one. The new one is wider, quieter, and dramatically more efficient. Most of its thrust now comes from a giant fan moving air around the engine core, not through it. Each new engine generation typically burns 15 to 20% less fuel than the one it replaces. The wings look familiar too, but their curves are shaped by computer models no 1960s engineer had access to. Some wingtips bend upward to cut drag. Some wings now flex visibly in flight instead of staying rigid. Add lighter composite materials and cockpits full of digital displays, and the plane keeps improving without changing its outline. Fuel is one of an airline's biggest expenses, so even a tiny gain, repeated across thousands of flights a day, adds up to real money. But even a radically better design has to survive contact with the real world. It has to fit into a world already built for the old one. A passenger aircraft never operates alone. It needs runways, taxiways, gates, jet bridges, fuel trucks, baggage systems, hangars, and trained ground crews, all sized for standard aircraft dimensions. A wing that's too wide won't clear the gate next door. A strange cabin height won't line up with the jet bridge. An unusual landing gear layout can crack pavement never built to take that load. The Airbus A380 proved how expensive this gets. Some airports spent hundreds of millions of dollars widening taxiways and rebuilding gates just to handle one aircraft type. Airlines don't want a plane that only works at a handful of airports. They want one that slots into routes that already exist. That makes the familiar tube and wing shape more than an aircraft design. It's part of a global system, and changing a global system is far harder than sketching a futuristic plane. Airports are only one obstacle, though. The next one is safety. Passenger jets carry hundreds of people at high altitude, often over open ocean for hours at a time. A new design can't just look promising in a simulation. It has to prove it can survive structural failures, extreme weather, hard landings, pressure cycles, and full emergency evacuations, a process that can take the better part of a decade before a single paying passenger boards. A familiar layout already carries decades of that proof. Pilots know how it behaves, mechanics know where problems show up, regulators know exactly what to test. A radical new shape raises new questions instead. How fast can passengers evacuate? What happens if one engine fails? Can every part be inspected easily? Will people seated far from the centerline feel more movement? None of that makes a new shape impossible, but every unanswered question adds time, cost, and risk. And commercial aviation is allergic to all three. Which brings us to the people who actually decide what gets built, the airlines. Airlines don't buy machines to look futuristic. They buy machines to run a business. That means low fuel burn, reliable engines, fast boarding, and, critically, commonality. If a new jet flies and maintains like the last one, airlines can reuse pilots, tools, spare parts, and decades of training. A radically new design erases that advantage. It might save fuel in the air while costing far more on the ground. New simulators, new hangars, new spare parts inventories. Passengers say they want more space in futuristic cabins, but at the checkout screen, most still pick the cheaper ticket, which pushes airlines toward lower costs, not bold new shapes. Manufacturers build familiar aircraft because airlines can run them cheaply. Airlines buy them because airports and crews already support them. The shape survives because an entire industry is built around it. Still, that doesn't mean the shape is safe forever. Some companies are betting it isn't. In the Mojave Desert, a startup called Jet Zero is building a full-scale prototype that looks nothing like a normal airliner. Fuselage and wings blended into a single wide flattened shape, closer to a manta ray than a tube. Backed by the U.S. Air Force and airlines including United and Alaska, Jet Zero says the design could cut fuel use by as much as half. Its first prototype is scheduled to fly in late 2027. Independent researchers are more cautious, questioning whether a passenger version can really deliver savings that large. And the design raises its own problems. Many seats would sit far from a window, boarding and evacuation get more complicated, and the whole aircraft may not fit a standard gate. Other ideas are chasing the same goal from different angles. Longer, thinner wings that fold at the tips to fit airport gates, or new propulsion systems, like hydrogen tanks or open rotor engines, that need entirely different airframes to work. For any of them to win, keeping the old shape will have to become more expensive than replacing it. That moment may be coming. It just hasn't arrived yet. Passenger planes still look the same because the basic shape was never the outdated part. The tube handles pressure, the wings create lift, the engines stay accessible. The aircraft fits the airports, and airlines and regulators already know how to run it. Almost everything inside that shape improved anyway. Engines got more efficient, wings got smarter, structures got lighter, cockpits got more capable, cabins got quieter and safer. The outside stayed familiar because changing it would force an entire global system to change too. So the real story isn't that aircraft stopped evolving, it's that aviation learned to hide its biggest advances inside a shape that already worked. The plane of the future may eventually look completely different, but before it replaces the tube and wings, it will have to redesign more than the aircraft. It will have to redesign the entire world that keeps it flying.